Today's lesson flows directly from yesterday, only this time there will be some variables in the denominator. Yesterday we saw that when we have fractions in our equations, we want to do the superfraction destroyer, which is multiply the entire equation by the least common denominator and then solve. These steps are pretty much the same thing, only we have to account for the fact that sometimes there will be variables, and actually in all of the problems tonight, there will be variables in the denominators, which also brings up the idea of restrictions. Let's start simply. We've got 3 over x minus 1/4 is equal to 1/12. So just like last night, we need to figure out what the least common denominator is. I think most of you can tell by looking that it is 12x. So you need to find the LCD. However, before we actually multiply the entire equation by the LCD, before we've done any kind of simplifying or solving, we need to first find the restrictions on the variable. Restrictions, sorry that didn't fit, but you get the idea. Restrictions are any value for the variable that would make a denominator equal to 0. And the reason is this. If I say 3 divided by 0, that means how many groups of 0 are there in 3? Well, I could put infinite groups of 0 together and I'd never get up to 3. So because of that, division by 0 is impossible. And therefore, we cannot have any solutions that would make one of the denominators equal to 0, hence restrictions. I'm going to turn the page and rewrite the problem to start over. So the problem is 3 over x, too close, 3 over x minus 1 over 4. 1/4 is equal to 1/12. We've already, I think, determined, or if we haven't already, most of you can see, that the LCD is 12x. Before I do that, though, I see I have a variable here. This cannot equal 0. That denominator cannot equal 0. Therefore, we state that, and if we did get a solution in which the solution was 0, we'd have to throw it out. So now that we've found the restriction, we then multiply by the LCD. As we go across, we can see that 12x divided by x, this is the same thing, makes the x's cancel out and leaves 3. So 12 times 3 is 36. 12x divided by 4 is 3x times 1 is 3x. 12x divided by 12 is x times 1 is x. I continue to solve. I see that 36 is equal to 4x, and then I divide by 4 and I find out that x is equal to 9. Now, after I get a solution, I need to check my restrictions. Is 9 among the restrictions on the variable? And the answer to that is no. Therefore, 9 is the solution. Let's try the next complicated thing. Here I have 2 minus x over 3 minus x is equal to 4 over 9. And here's just a general thing that I want you to try to get in your heads. Anytime you have an equation in the form of one fraction equals another fraction, a fraction on either side, one fraction on either side, you want to cross multiply. It's the easiest thing to do. However, before we do that, and that is actually based on the whole idea of this fraction destroyer business, but before we do that, I have to say I've got a variable in the denominator, and because division by 0 is impossible, I have to say 3 minus x. Normally I would do this to the side. Actually, let's do it to the side so that you don't confuse that with the solution. 3 minus x cannot equal 0. So I could subtract 3 and then take the opposite, but obviously I can get x alone on one side if I do this. So 3 can't equal x. X cannot be 3. Now that I've found the restrictions, I go and I solve. I say 9 times 2 minus x is equal to 4 times 3 minus x, which means 18 minus 9x is equal to 12 minus 4x. I want to get my variables on one side and my numbers on the other, which leaves me with 6 equals 5x, and that means that x is equal to 6/5. You can keep it in this form. Always go back and check the restrictions. It's not a restriction, so this is the solution. Now, why we call it fraction destroyer on steroids. So, I'm going to start way up at the top here because I want to have enough room. 2 over b squared minus b minus 2 over b minus 1 is equal to 1. And that is over 1. So I need to find the LCD of these three denominators. The first thing I need to do is factor the denominators. I think you know that denoms means denominators. And really, the only one that is factorable is this one, because the first step of every factoring problem is, you got it, take out the GCF. Minus 2 over b minus 1, bunch of polynomials in parentheses, and that's 1 over 1. And then, since we've done this before, I'm not going to really spend too much time on it. I want to remind you, you want to say what's missing. If I need to have a complete collection of factors, they all need a b, and they all need a b minus 1. So that is the LCD. But before you simplify, you need to do the restrictions, which means that b, in this case, b can't, every single factor that has the variable in it has to be taken into consideration. B can't equal 0 because there's a b here, and b minus 1 can't equal 0. 1 can't equal 0, but we don't have to worry about that. 1 will never equal 0. So the only thing we have to solve in this little restriction thing is to say that b can't be 1. So these are our two restrictions. B cannot solve and equal 0, and b cannot solve and equal 1. Well, now we need to multiply by the LCD. I'm a little bit out of room to show this. So I think what I need to do, where we were was 2 over b times b minus 1 minus 2 over b minus 1 equals 1 over 1. And since I have more room on the right, I'm going to show the multiplication here. The LCD is b times b minus 1. So, working with this and this, you can see the whole thing cancels out and leaves 2. Looking at this fraction, the b minus 1 cancels out, leaving b. So now I have 2b, because this number, this divided by this, leaves b, and then times 2 is 2b. And you can see here that this is missing the entire thing, b times b minus 1. Once I've multiplied by the LCD, so that would be the next step, now I need to solve. And hopefully you all remember that when I have an exponent, that means it's a quadratic equation, and I have to throw everything out the window and get one side equal to 0, factor, and solve. I also want the quadratic term to be positive. So I'm going to bring everything from the left side of the equation to the right. I will add 2b here, and I will subtract 2 here, and that leaves 0 equal to b squared minus b, plus b minus 2. If you remember your quadratic equations, now we say we have to factor. This sign tells me they're different. I'm looking for numbers that multiply to 2 and subtract to 1. They are 2 and 1. Since this sign is positive, the 2, the bigger one, goes there. So now, if this number times this number equals 0, one of them is 0. Notice this looks just like the restrictions, only this is when we do want it to be 0. So b can be negative 2. Or b can be 1. However, unfortunately, it's on the other page, but what we found earlier was that the restriction said that b cannot equal 1. Therefore, we need to throw this solution out, and the only solution is b equals negative 2. Chances are, if you're doing your homework and you get a solution that is not the same as the back of the book, especially if the back of the book says no solution, chances are that you missed the restriction. So, that's how those work. There are also some word problems tonight. I want you to refer to page 306 right now. I will look at number 2. It says the sum of a number and its reciprocal is 13 over 6. Find the number. So, as always, we have to write down in words the unknowns. The number is an unknown, but so is its reciprocal. If I call the number x, its reciprocal, as you know, is 1 over x. So the sum of a number and its reciprocal is 13 over 6. Well, as you can see, I have a fractional equation. I need to say over here, x cannot equal 0, finding the restrictions. I hope you can see that the LCD is 6x. That gives me 6x squared plus 6 equals 13x. So since I have a coefficient here, that means I need to subtract 13x. Don't forget in quadratic equations what the proper order is. I need to put them in terms of decreasing exponents. So this is going to be a little bit hard to solve because, can you see? I have a coefficient. It's going to take some guessing and checking. I'm going to say, what if I have 3x and 2x, because they multiply to give me this, and I know my signs are both negative, and let's say 2 and 3, just as a start. Oh, it's right, because this is negative 9, and this is negative 4, and that adds up to negative 13. So moving over to the right, what that means is 3x minus 2 is 0. Or 2x minus 3 is 0. So this problem actually has two solutions. The solutions are 2/3 or 3/2. Both of them would work. I think you should be okay with the rest of this.